All the best, beta.
Yes. Hello friends, I am Rishi Mukhopadhyay from Bharat, and today I am going to be explaining composite design pattern. So, as the name suggests, it will be composite. So, as I talk about composition in UML, so composition is when a bigger object is getting composed by smaller objects.
Right.
Same here, but there is one difference in composite design pattern. In here, there is a pattern. Unlike in composition, the wheel was being composed by the car, but there was no pattern. Instead,
so what? Yeah. Go ahead. Yes. Go ahead.
But in here, there is a pattern.
No, now you can. What is car and wheel? So you can, whatever you were explaining, the car and wheel example you were mentioning, right? So that means what Edith is trying to say that okay, you can go ahead with it. The car is composed of wheel, but yeah, go ahead, better, go ahead.
So car is composed of wheel, but they will have no pattern.
So there was no relationship between composite design pattern and car and wheel structure. Right? Yes. So that means there is no pattern. Car is separate, wheel is separate, but again, it's a part of composition, UML composition. But here, the composition, the same composition, UML composition will be.
It will be a little different. The hierarchy will be different.
It is different, and it will follow a specific pattern. That's why this is a design pattern. So that's why the composite design pattern, right, madam?
Yes.
Right. Yes. Get better. Get. Go ahead. Very good. Yes. Very good. Go ahead.
So, in India, there was a famous scientist known as Conrad. He had explored that.
Conrad, yes.
He had explored that something can be divided into smaller objects, but there is a limit of it getting subdivided. So, con means a molecule.
Right. So that is a corner. The corner. Yeah. So what he did was trying to say, actually, he did explore all this India stages and scientific theories. Many years before other did the exploration. So there was a great Indian scientist called Conrad, who found that that's what Conrad, right? The Conrad you were mentioning, right? Who found that something can be subdivided again and again, but at a certain point of time, the maximum limit will be reached, and then that cannot be subdivided anymore, right? Yes. Then suddenly he discovered, that's a great idea. That means it is the smallest possible division which cannot be divided any further anymore. And that's what he named as Kona, according to his name, Kona. That means the particle. That means which later the European, the Rutherford explained with the molecular theory, but for the students of universe, for the global students, this is strange. Conrad, discovered it many years ago. The European Rutherford, right, madam? Conrad explain all these things, and these are all well documented structure of well documented. These are not verbal; these are well documented, statements found in Indian ancient Sanskrit textbooks. So Conrad was a great scientist, or rather, we used to call all the scientists as sages. They were sages, and so molecular theory, actually the first proposal came from Conrad, and it is all well documented. For the global people of the universe, you must know that we have discovered many things. On our original. Maybe you must be astonished that even the Newton's all laws of motion, these have been just absolutely ditto copy from the original Sanskrit. Sanskrit, laws of motion. So whatever Newton have done, original Sanskrit version. Okay, these are the exact translation of the original Sanskrit, version of our, what is the laws of motion or whatever. Okay, so we discovered all these things, and these are although actually, yeah, this is something, something of still, yeah, let's call a spade a spade. This is some kind of stealing process. But the unfortunate thing is that I mean, the Newton, yeah, Newton was a great scientist, but he should have given the proper what is that called, proper source, that okay, I have taken the source from this person, and maybe anyway. So these are all established facts now, everybody knows it. But because this is, because people or the kind of next generation of Bharat should know what is truth. And because when everybody is seeking truth, then they should also know that before Rutherford, Conrad found the basic theory of molecular moles and molecules, and these are all well documented. And even people should, the previous strains across the globe should also know that much before Newton came out with the laws of motion, we have well documented version of laws of motion, and Newton just took it from that version and translated it in English, exact translation. Okay, anyway, go ahead, better. Go ahead. Come on, very good.
So the same thing goes for composite design pattern. In here,
right.
There's something known as the leaf class, which cannot be subdivided anymore.
Right. So, like a molecule, right? The molecule, it cannot be subdivided. Yes, very good. Yes. And so, yes.
Let me describe the hierarchy of composite design pattern. So
yeah, you can show the UML is open, but you can show the UML structure.
So as you can see here, it is our root class, which is our main interface, which can also be known as the component.
Right, component. Yes. That component, I mean, we have taken the term from the Gang of Four, right, Beta? Yes. Component, right? Beta, component. Yes, Gang of Four books. Yes. Go ahead, Beta. And then the point.
Yes. Then the point, which is our leaf class in here, is inheriting the shape class.
Yes.
And as you can see, we have noted it here, our leaf class.
Yes.
So after that, there is the line class.
No, hang on. So at the same level point, we have another composite step, right? But the better composite step is again, which can be divided in further division, right? Better.
Yes.
Right? One is the point, which is a leaf, and then there is the composite step. That means which is again composed of other kind of steps, right? Better.
Yes.
Other kind of same kind of leaf. And then why? How? Because how we are implementing it, because it has a vector, right? Better.
Yes.
On the composition as a vector. So that means which will hold the parts of the different parts, because these are all kinds of shapes, same pattern, right? Same. Yes. Unlike car wheel, these are all from the. So that's why it has a vector of shape, right, madam?
Yes.
So, yes. And then from composite step again, because composite step again it can hold other shapes. So then from composite step we have other lines. So what is line?
Yes.
Go ahead, madam. Line will have.
So line will have 2 points.
So that means point is leaf. So line will have 2 points. Very good. And then rectangle.
And rectangle will have 4 lines.
That means again, so rectangle will have 4 lines. Again, 4 lines. Each line will have 2 points. This way, the whole hierarchy will come, right, better.
Yes.
And then the basic idea of the display method is right. Once you call the display method of the composite step, it will traverse to the vector, and then it will display one by one, right, better.
Yes.
So for example, in the rectangle case vector, so display will first it will display the line. So once it goes to display the line, it will go to the ultimately what is that called leaf of, I mean, the further subdivided, that is point, and then ultimately point will be all right, better. That's right. Great. So it will be very good. So see the Babu, show the comments. For all shapes start in the shape. Shape is the vector, right? Better vector, yes. Right?
Yes.
Shape is the vector. And can you enlarge the full skin? This whole full skin. Is there anything called full skin? I think there is view. See view full skin. I think we'll make it full skin. Some. One highlight. Yeah. No, okay. It's okay. Let it be. Very good. So see, for all shapes, right? Better. That's right. It will traverse to the vector, right? Container, and then it will. Yeah, very good. So this is the So you go ahead, whatever you want to add, very good, very good. So we'll do the coding and C++. Yeah, very good. Anything add?
So in the shape, we have kept an variable known as parent. So
yes,
which will be going down through the subclasses and
that is protected, right? Yeah, it will be kept as protected. Yeah, it will go down to the
so
subclass.
that's how it will be going through the subclasses, and
right.
the point will have line as the parent.
Oh, I mean, no. I mean, so in case of line,
Yes.
the point will have a, I mean, the point's parent will be line, right? Better, right? Similarly, in case of rectangle, the lines, the full line parent will be the rectangle itself. Then each and every line will have two points. Full parents will be the line, right? Better, right? This way, the parent will be again one by one, and because composite, right? So this is hierarchy, right? So everybody will have parent-child relationship. And by the way, Ridit, I think you can explain. I mean, we can. Let me say, this get parent is a good idea of. I mean, to implement whatever did yesterday, a kind of chain of responsibility design pattern. Actually, this way we can send the command to the top level of the UI hierarchy. Right? But actually, by the way, for the friends of Reddit, I mean, this kind of composite design pattern is the most popular design pattern used in better UI widget. Right? Better widget. Starting maybe say Android widget or maybe any kind of widget which Reddit export many years back, 2 years back, Android. So widget and these are all parts of they all form this. Better tomorrow first task na. These are all parts of composite design pattern, right? But and this parental chain of responsibility or the commands these have been passed to the parent. Actually, these are these are used for many kind, maybe like the dirty area painting and all these things. These are these are dirty area reflection, all these things. So these are part of a specific structure and framework, but these are the basic way of idea of graphical user interface widget development. And this composite design pattern is very popular. In fact, this is the only design pattern which is used in the most of the widget factory or widget of UI framework. Right, Beta? Right. We will explore maybe after you do this. Maybe after not again we will start exploring the Android source code, and then we will find out that composite design pattern being used in the Android widget. Okay, again, that's all the things you studied long time back. Maybe with starting from container and all these things, layout and right. Remember, I focus on layout and all these things. You are part of them all composite design pattern. Okay, ultimately it will go to trickle down to the button and then check boxes. These are all okay. Okay, better. We will discuss all these things. We will explore all this Android source code, but later on. But let us not. I mean, vacillate. Let us not move away from our right specific direction that we are going to learning all these things to explore. But better the Manta flow, right?
Yes.
Blender source code, and specifically the Manta flow, right? For understanding the fluid. Better show yourself to understand fluid simulation. Very good, better. Very good. Anything you want to before starting the coding or before showing? That it. Anything you want to add before starting the coding, or you will start coding now, right? Right, better. Straight away you will go to coding, right, better? So yes. In camera coding, right, better? Yes. All the best. Okay. But I think better. I think P should be small, right? Better the parent P. Yeah. Naming and naming convention should be properly taken care of. Very good. Better. So for the students, global students or registered students, this because we have taken it seriously to give a ID associated with each object, right?
We have already done it in our canonical class.
Yes, yes. So in the beginning, when Ridit was explaining the canonical class and all these things, and these are all part of the Ridit block, technical block. So we are taking the boost UUID, that is the unique ID identification, and Ridit got the idea from Java, right, beta? Java classes. What is that called? Hash code, right, beta? It was Ridit's done that Baba, can we have similar kind of thing in C++? So it will boost this unique ID, right, beta? Right? Yes, yes, yes. Right, but is it, am I audible?
Yeah.
Yeah, okay, great, 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 very good, very, very good. So that's why after that first development of the canonical class with the boost UID. So we have taken it upon that mostly we develop our C++ classes with this unique ID as a as a member variable, just like it's a job, just as a something like the what is that called, beta? The hash code of Java object. Yes, and it was frankly speaking, it was actually absolutely this plan, because when we did, of course, boost was not there when we did all these things in mid 90s. Then these kinds of concepts was not there in C++, but anyway, they did this have learned because these are these young generation of engineers are you know, have already learned many things which we couldn't just think of at that time. Anyway, great, 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 great. We are doing this. Okay, very good. As a reference to the parent. Yes, 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 reference to the parent. And again, in accordance to our yesterday's discussion, it is basically done for what is that model? To pass the chain of responsibility, right? To create the chain of responsibility from the bottom to the top, and because this composite design pattern is used mainly for widget development, right? For widget development in framework, and so that is needed. This is needed. The parent, from the child to its parent is needed for many aspects, maybe like what is that called, beta? Duty area painting and all these things. So these are, we will discuss all these things later, but not now because this will make whole thing. Come. Yeah, go ahead, beta. Very good. Congratulations. Get better. Get speed. You are showing. Yes, very good. Yeah, very good. So I think it is a pure virtual function, right, beta? Because yeah, it is a pure virtual function. Beta, but yes, it is very good. Yeah, so it's again pure virtual function again, right, beta? So we'll discuss it. We'll definitely discuss all the things why it is why pure virtual function. Yeah, so great. This is the void. So this page is done. Parent is done. Add, remove, add, remove. So add will take some parameter, beta. Add what?
Yes.
Add will take a step start parameter, right? Step start, and yes, this will add, and then it will again. So as these are not kind of what is that called? So maybe there will be a default. I'm just go ahead. Display ID. Okay, great. So this will display the boost ID, right? Beta boost UI, right? Very good. We are going to display the what is that called? What is shift with ID, right? Maybe shift with ID, right? So shift ID. Okay, great. Shift ID. Very good. And this is the ID. ID is the boost ID, right? But yeah, boost ID. So this is the shift ID. Very good. And then app shaded and will hang on. I think better. I think the add will have void, right? Beta add will not return shift, right? It will not return the shift, right? It will void. I think, right? Void. Yeah. Because we are not returning the step that we are adding. Yeah, we can do that, of course. Whatever step we are adding, we can return that step, but for keeping a reference, but that is not needed because anyway, yeah. So yeah, void, and then very good. So void step, very good. So very good, fantastic, great. You have picked up the speed. Very good. What is this? Step. What is this called? Virtual. Oh, virtual. Yeah, virtual, and in the sign will be in front, right? Not in the back, but not. Yeah, yeah. And then this is, yes. Yeah. It is a virtual destructor, and Yes, virtual descriptor. Yeah. So virtual descriptor, and so again, right, probably, and did it. So just one. So again, these are virtual. Yeah. Okay. These are, you are making it virtual. Okay. So again, you are not making it pure virtual function because anyway, because anyway, we will discuss all these things later. But the design, very good, class, very good. I think it's okay. Great, better, great. You have picked up great speed. Very good. So build, you are incremental building. Very good. So all zero errors. Very good. Congratulations, better. One done. So the top class root component, the component class is done, right? According to the gang of four component class, top root class is done. Very good. Now go ahead and
now we are
define
going to do the point class, the leaf class. So
So now we are going to add the list class, right? Beta?
yes.
Right. So point should be again point. Oh, header file, CPU value are deleting. So we are making all the things in top part of the header file. Very good. So point should be derived from. So first of all, colon. Point should be derived from beta. Point should be again the root class, right? Yeah. It should be part of. Yes, very good. Hierarchy has to be mentioned. So publicly deriving from shape. Very good. Very good. Very good. Very good. Very good. Very good.
Wait. Let's actually, can we make this protected?
Which one, beta?
The
Step. Yeah. Private, yeah. You can make the private protected. Yes. Make that protected. Make private, make protected. Make it protected. Just yeah. That's very good. Yeah. You should be protected. Yes, because the ID has to be calculated down to the all of it, right? ID and parent. Yeah. That's right. Very good. Yeah. So now private. Now this is the part of the private because so we want the point that means x coordinate and y coordinate. Right. So int x and int y, right? Better.
yes.
Index, yeah, well, yeah, index and index. And again, this has already explained that why he's keeping all the things in as a stack, right? In a not pointer member variable, right?
I've written in the block.
He has already explained it in the blog because he doesn't want to get in. Our plan is to not make it very big so that we are going to. Jidit is trying to. Jidit has used the implicit, what is it called, assignment operator and all these things, so that as you know, he has already explained it in the technical blog that if you don't offer any assignment operator, then the compiler will supply one assignment operator. But because that assignment operator uses the salop operator, that is salop operator. So to avoid all kinds of complications, we will be using all stack-based member variable, right, beta? Yes. So x is equal to 0. Yes. X is equal to 0. So this is the default constructor, right?
Yes.
The default constructor. Very good. Default constructor, and then any other constructor you take. So point. Then you take int x and int y, right, beta? Two parameters you take, right, beta?
Yes.
Int x and int y. So int x or whatever you name. How do you name it? Int x, right? Int x. Yeah, very good. Int x. So in parameter. So these are the in parameter. This is the naming convention we are mentioning, but anyway, so x is equal to very good. Very good. So this is how the x is equal to in x, and then y. So this is the one. So this is what two. So we have got two. What is that called, beta? And then beta. I think both will call the default shape constructor because ID has been generated in the shape default constructor, beta, right? Both will call the base class. Yeah. Both will have to, yes, shape default. Shape void. Yes, this one. No. No. Yeah. Only the default shape. Only the shape default. The shape. Yeah. What shape? Only you have created in the shape. Yeah, shape. What shape?
Yeah.
Shape. So come on, start typing. Yeah, start typing shape.
So let's now do the display method. First, let's do the add method. I think so.
Yes. So because these are the point is a leaf class, so we cannot add it. So maybe we can show some sorts of exception, but for the time being we are keeping it simple. Like a simple method. Right, better? Yeah, shifter. It will take shifter, right? But because it will take parameter, right? Sorry, variable, right? What is, yeah, shifter S, yes, and then shifter S, and then it will just make you see out that we cannot add anything to the point because point is a lifter, right? So as the yesterday discussion, we know that we cannot add anything to the lifter. Right? That's why error. So point is the lifter. Yes, yes, this is the lifter. What is the point? Is the lifter. Very good. These are error points the lifter. So maybe later we can change it to an exception or normal. For the time being, we're making it simple. Just a message. Yeah. Point is the lifter, so we cannot add. Very good. Get going better. Get going. Fantastic. And then similarly, for removing also, we cannot remove something from point because naturally if you cannot add anything, naturally you cannot remove otherwise, right? Remove and then very good. Very good. Good. Very good. And then shapes are yes, very good. Yes, very good. And then no, yeah. Ah, yeah. Uh-huh. Yes. Yeah. Very good. You can copy anyway. You
No,
don't want
writing is better.
yeah, very good. That's right. That's right. Should avoid copy. At least in the beginning of the page, you should avoid start copy. Very good. Yes, you have got the idea. Very good. Come on. There are points. So you cannot remove anything from points because naturally, guys, right? Friend, there is students across the globe. You cannot add anything to point. You cannot add, remove anything to point. And virtual about this distractor should be that curly brackets. Curly bracket. Distractor has not been implemented.
Yes.
Curly brackets.
Wait, let's first do the delete function.
Oh,
After that,
display, right? Display. Yes, display function, right? Void display. Yeah. Now this time we are making it a concrete display method, right? Better because there won't be anything, and after that list.
So
right?
we have implemented it here. So
yeah.
that
So your virtual function we are implementing in the first concrete class. See how x and y. So maybe the x, whatever, the beginning of the point, whatever you can. So x is right. First x, but better first is x,
yes.
right? Better.
First.
Yeah. First x coordinate. Yes, x coordinate. X is equal to space after x. No. After equal to sign it will look good better while display. Yes. Then then the x right. Yeah, and then the x, the member variable x. Yes, and then maybe the end. No. Go ahead. Maybe with,
No, we will have to do the y also.
yeah. So maybe with space, you can give a space. Yeah. Uh, no, after okay, we'll do all this thing later. Okay, so very good. So, very good, and then beta this yeah, before the capital Y inverted comma space, it will look good better. Yeah. After that. Yes, it will look good. Yes. Very good. Very good. Yeah, it will look display properly. Very good. So x and y are the two coordinates of the line. Very good. X and y. Very good. Points, right? Points. X and y. Yeah. Very good. Great.
So now there is going to be two methods. One is get x and get y.
Okay. You can do it. Yeah. So as we did learn earlier Java, so we are taking the same concept of get a set.
We should always keep
But
Yes.
get it, right? But yeah. Return x, right? Get it. So get a set. Again, Babu gets to be G should be small bit. Oh, don't do this. Don't. G should be small bit. Yeah, get x and then return x. Yeah. Yes. Return x. Get. And then similarly for get y, the similar get a set concept because we did was first actually learned Java, so many things we are still maintaining like that. And the business is maintaining the same thing. So get X and get Y. Okay, get done better. Congratulations. So you can compile it, maybe the build it so that everything becomes okay. Then you will understand. I think and build. So this is how this how you should do. So very good. Congratulations. Now go ahead for the next level, same level class, but it will be a composite step, right, madam?
Yes.
Point is the lift class. Lift class is done. So very good.
This time we are going to do line.
So yeah, no, the composite step, next step, but a composite step, right? But yeah, line, but that will be part of the composite step, right? But So maybe better. I think our recording time is. Chalo beta. All right.
Okay.
Start. Share the screen beta. Screen is not shared beta.
Yes.
Yeah, very good. Get. Go ahead. So now you are going to add the next at the leaf level, right? Beta composite step, right? Beta. Very good. Come on. Next level. Yeah, composite step. Very good. This is public. Again, initial public. Then step. Okay. This is the composite step. So which may hold a other shape, right? Beta, right. So set apart and then of course it will have a CSV file delete. Very good. So because we'll tell why we are deleting all the CSV file because we are having vector, that's the template. So that's the reason. Anyway, vector. So vector, it will have a vector sector, right? Because so input vector is there, vector is in vector, right? Because I think yeah, triangular, right? Because yeah, vector, and then
Since vector is a library, so we have to do it in
yeah. And beta, you have you done the using namespace SCD? I think you have done it already, right? Using namespace SCD in the top level class. Top level class. That's the shape class. But shape class. You should do it in the shape class, right? Yeah.
Yes.
You should do it. Yeah, shape class.
I think so. Yes, I have. I have.
Oh, very good. Yeah. I know. Yeah. You have already picked up pretty. What is that called? Beta. I think we'll pass it in the because there are limitations. So you can discuss it. Right? What we have discussed that we will pass it in the through the as a parameter in the what is that called constructor, so that so there is no limitation of the number of shapes while creating.
Yes.
And we'll running through the duty of creating the vector to the client, right? Because when the client should know okay, how big maybe the drawing, how many maybe the picture, how many steps it may have. So we'll create the we'll leave the responsibility of the determining the size of the vector while creating it to the client, right? Better, and we'll leave it. We'll pass it here. Yes, that's the idea. So we'll because the person who will be using this package when he is going to create the when he is going to create the drawing, I think you can name it in shape of whatever. Yes, okay, great. Yeah, so we're leaving the responsibility on him to uh, make it to determine the size at that time. Right? That's why we are passing it to here, right, Peter? So that we're not obstructing the by creating the vector. We are not obstructing the developer to determine the size. We are leaving the responsibility to the client, right, Beta? In the main, right? So it needs the default constructor. Now you may explain why are you calling the base class constructor, because the ID has been generated in the
in the constructor, in the default constructor.
And because it has a default constructor, so you must have a default constructor of composite shape as well, right, Beta?
Yes.
Composite, because that's how because default constructor, once you have the default constructor on the top level class, you should have a default constructor of a what is it? So you can do it either you can shape it or null, you can do it, or just you can call the base class constructor.
I'm going to call the base class constructor.
Yeah, do it only that thing, because anyway we are not going to use it, because we will anyway pass the we'll always create the composition with anyway go ahead. Very good.
So now let's do the add method first.
So because this is again so we'll simply add it to the vector, right, Beta? Simply add it to the vector. So that's the step. What is the step?
Yes, it's not shapes.
Yeah, no. Here is a vector. This vector should be shapes, right, Beta? Name is the shapes, right? Member variable shapes, right? Member shapes. This one, second one. Shapes, yeah, shapes. Yeah. Add inside add. Yeah, inside add. Shapes. Yeah. Go ahead. Type. Shape. Yeah. This is the member variable. No, not yet, but shape. Shape dot add vector. What is the name of the vector? Shape, right?
Yeah.
You are going to add the shape and then what is that called? Pushback, right? What? How do you do it? Pushback, right?
No. First we have to do the start parent. First we have to get the parent, na.
Oh, first you will have to say yes, yeah. First you will have to set the parent is equal to this, yes, and then you will push it to the yes, this minus, yeah, this, yeah, and then very good, very good, very good, and then shapes dot add that because it's a
Pushback.
shapes dot pushback, yeah, pushback, and then very good. So guys, very good, very smart kids. Say yes, but pushback. Which one should we say? Yes, yeah. So they are very, very smart. They say first we are setting the parent because it's very important. Once you instead of shoving inside the vector, we are first setting the parent and then we are pushing it to the with the complete object. We are pushing it to the what is that called? Vector, the container, right? Scepter, better scepter. Or
Yes, I always
scepter, and then I think you have to be very careful because normal.
Wait, let me do it.
Yeah, good. I think you can do oh, remove. Yeah, remove. So very good. Remove. Very good. Remove. Yes. Oh, yes. Okay. Then how will you get the position? So STD and then you search it, right? Search. Very good. Very good. Search. Very good. Then you will filter it. Very good. Very good. Very good. Very good. Very good. Oh, great. Stuff. Very good. Very good. Very good. Very good. Very good. And very good. And then shift. Very good. Get. Oh, great. Begin is done, beta. Begin is done then?
Yes.
Then end, right? Or what is that called?
I think it's end.
No, I mean, see, what is that called? I have forgotten actually. You shift dot end. Very good. And very good. And, no, end, but I think end is the method. End is the method.
Yes.
Method. Yeah. End is the method. Yes. And then S is the step. Yeah, very good. And probably anything else? I think.
At the last, we have to add another end without the shape.
Okay, remove anything.
I think so. We have
Done. Yes, yeah, very good. Great. So basically, it is I think filtering. Yes. Anything, I think. Done. Very good. Great. I think it is.
wait. One. Wait.
Great. So you are. So how many? In so shape dot end. So one is remove. Babu, remove after remove. Yeah. You should start from here. Yeah, remove.
Yes.
Yeah. And then, no. Babu, remove that. Remove that. Closing bracket. Remove will start. STD and remove.
Yes.
Yeah. This one will be there. The end left side. Backspace. No. Backspace. Yeah. Remove and then it will come. Yeah, but you gotta remove and then. So remove, then shape dot begin, shape dot ends, and then
So let's do the display method now.
I think you can make it virtual better, right? Because you don't have particular expert. Yeah, virtual. So virtual, and then you have implemented. Yeah, very good. Now,
so we are going to traverse, as I have said in my blog, we are going to traverse the vector through the shape.
We are not, vector shape. We are not going to use iterator because we will use the whatever size and for loop. Just a simple for loop better because you are targeting many levels of students. So let's not use iterator. So int I is equal to 0 and simple like the step dot size, right? Better step or what is that? I less the size, right? Better step dot size, right?
Shape dot size. It's same as Java.
Yeah, simple. Yeah, yes, the template class, the container class, and then I also, and then now you'll get it get one, and then display, right? So
I think so. We have to make semicolons instead of.
Yeah. Semicolon, yeah. So now go ahead. Yeah. So first you have to shape dot get, right? Now add. What is that called? Shape.
Yes.
Shape. So how will you get it? Add, right? But add.
Yes.
Add, and then I, and then the display. So it will return a, what is the return? It will return because shape stuff, so that means the pointer, so then display, right? Very good.
Yes.
So that's how it will traverse from 1 to 1. Very good. Get. So this will traverse from 1 to 1. Very good.
So let's repeat our project.
I think it will be okay. Done. Very good.
Yes.
Get. Very good. Get. So now will you do the
So now we do the line class.
and the rectangle class, right? But line and rectangle, that's two you are going to display, right? I mean the demonstrate, right? So basically, guys, for the students, these lines and rectangles are all part of composition step, because line will be composed of 2 points and rectangle will be again composed of 4 lines, right? Right?
Yes, because they're not leaf classes.
These are not leaf classes; these are all composite classes. Again, as the continuation of the first discussion, that these are the specific design patterns. These are all part of UML composition, but then again, this composition is actually basically abiding by the specific hierarchy. That what is called dependency hierarchy. I mean the inheritance hierarchy, right?
So,
that's a pattern.
yes.
It is a maintaining. It's maintaining the pattern. Very good. Congratulations. Very good. Good.
Yes. So line will be consisting of 2 points, and the rectangle will be consisting of 4 lines.
Okay. So we are putting the. Beto, have you done the vector as a protected, right? Beto, yeah, you have done it in the protected, right? Beto, vector.
No.
Yeah. This should be protected, right? Beto, protected. Yeah, get. Because again, we are not using greater than zeta, because we want this to be calculated down to the all the
It's subclasses. All the subclasses.
Very good. Get better. Get. Congratulations. So now we will do the line
Class.